Okay, so we calculated time final and y final, but remember this is all for the first part of our example here, okay? And so now we need to figure out our last part, this x final. So here's my work for the x direction, okay? So I need to pick an equation. I cannot use two of the equations because the acceleration is 0. So I need to pick one of my remaining two where we could choose either as long as it has x final, and they both do. The third equation down is usually the easiest to work with, and so I'm going to choose that one. So I have x final equals x initial plus velocity initial in the x times by t final plus 1/2 acceleration in the x t final squared. Okay, and it's already solving for what I'm looking for, so that's great. So let's just get rid of our 0 components here. So x initial is 0, acceleration is 0, so this whole component is 0 because anything multiplied by 0 is 0. So x final will equal velocity initial in the x direction multiplied by t final. So velocity initial in the x, it's the 4.4 number. I'm going to times that by the 2.28 time component. Okay. And I get an x final of 1.2387. Okay. Now, it's important to note that that's for this first part. Okay, that is the 1.2387 meters. And now I need to figure out the second portion here. Okay. So we figured out everything for part 1. We're going to use that information to solve for part 2. And what I want you to notice now, there's always multiple ways of going about and doing these kinds of problems. And I'm going to, if I have time, I'm going to film another video showing you a different way of doing this. But as the observer, you choose where the origin is, right? And so we've already finished the first half, so now we're looking at the second half. So I could leave my origin there, or I could move it, or I could move it there. It doesn't matter. Again, that's up to you. You just have to follow through with your math. For this example, I'm going to move it. So for the second half, my new origin is going to be right there. Okay. Okay. So let me just quickly, just so you kind of see what's going on. Okay, so I'm looking at the second half now. And so we chose our origin to be right there. Let's make our lists. We have x components and we have y components, and this is all for the second half here. So x initial, y initial, all those things. Now what I want you to do is, for both the x and the y, I want you to go through and see how much of this you can fill out. So hit pause, fill it out, and then come back and see how you did. Okay? Okay, now, y initial, y final, velocity initial in the y, velocity final in the y, acceleration and time. Okay. In the initial position, we're starting here and we're ending there, right? So initially, for x, I'm at my origin. I don't know the final position. In fact, that's what I'm solving for, right? I figured out what this first half is from earlier, and now I need to figure out the second half. That's what I need to know. Velocity initial in the x, remember how over this entire path, the only force is the force due to gravity. So that means acceleration in the x is 0. And so our velocities stay the same. So it's the same as from before. We still have that 4.409 number. Okay. And again, this is the same. Okay, it's the same as that one. We don't know the time component for this other part. I hesitate to say second half just because we're starting up on a table. And so we can't make these assumptions like it takes the same amount of time to go from here to here and then from there to there. And it's not going to be the same distances as well. Okay, so we're just looking at the second part of the problem. We don't know the time for the second part. Y initial, here's my origin. I'm starting way up there, and that was my Y final from before. So if I take my Y final from before, 2.68701, okay, that's how high above my origin I'm starting, and then my final position is going to be at the ground, which for the Y direction is the origin. Velocity initial in the Y. I'm starting at the very top of this arc, right at the top of the apex. And in the Y direction, when an object is right on the top of that parabola, then its velocity initial is 0 meters per second. It slowed down, and then it stopped for the briefest of moments, and then it came back down, and we're looking at that moment of where it stopped, and then it's going to speed up as it comes back down. Velocity final, we don't know. The acceleration is due to gravity. Okay, so we're solving for x final. It turns out there's not a kinematic we can use right away. We need to know the time component. So we're going to go over to the y to do this. Now these kinds of problems should be familiar to you. And if we look at this, see how the velocity is all in the x direction, we don't have any in the y. It's exactly like this second half, it's as if we're shooting the cannon perfectly horizontal. Okay? So you should be becoming really familiar with these kinds of questions. So if I do my work here, so here in the y, and I'm solving for time, I want to choose an equation that does not have velocity. Okay? And so or velocity final. So when I look at my list, there's only one equation that does not have velocity final, and that's the third one. So y final equals y initial plus velocity initial in the y multiplied by time final plus 1/2 acceleration in the y time final squared. Okay? And we have a y final of 0. And we have a velocity initial of 0. And so anything multiplied by 0 is 0. So we have 0 is equal to y initial plus 1/2 acceleration t final squared. Let's solve for the time component. Okay, so I'm going to rearrange this to solve for time. I'm going to start by subtracting that y initial to the other side. Okay. And now I want to get time by itself, so I'm going to divide by 1/2 an acceleration. Okay. And right now we're equal to time final squared. The squared is still there. Oh, I can't see that. Let me. Okay, so I divided by the 1/2 and the acceleration. Okay. And now we're equal to time final squared. So there is a squared right here, and so we're going to take the square root of both sides to get rid of that. Okay. All right, we have those numbers. Let's put that in. So I want the square root of negative my initial. So I'm going to go up and grab that 2.6 number divided by 1/2 or 0.5 times by a negative 9.81. Okay. So I'm getting a time final of 0.740143. Okay. That can go over here as well. And now I have enough information to solve for the x final. So I can use either equation. The third one that we use the most often in these kinds of situations works the best. So x final equals x initial plus velocity initial in the x multiplied by time final plus 1/2 acceleration in the x. Time final squared, acceleration is 0, x initial is 0, so x final equals velocity initial in the x multiplied by time final. Okay, so I'll take that 4.4 velocity initial number, and I'm going to multiply that by the time final number. And so x final for the second half is 3.26392 meters. And again, reminder, that is for the second half. So I'm going to take the x final from the first trial, or the first part. I'm going to take x final from the second part to figure out where I am putting my target compared to the base, where I'm putting my target compared to the base of the table. Okay, so let's see, x final for the first half was 1.2387. I'm going to add that to x final of the second half. And I'm getting a final, an x final total of 4.50262. And then let's now look back at our sig figs. We were dealing with 4 significant figures, so 1, 2, 3, 4, and that will round up. So we'll have 4.503 meters. Okay. That's where I'm going to place my target. Okay, so that's one way of going about these kinds of calculations, and I will add another video showing you a second way of doing it, and you can decide what works best for you.